each and every layer in a voice reference models, it deals with or works with number of protocols, and all the sessions will be communicated or will be combined and will be transmitted as a single channel. That is the concept of multiplexing here. It is a connection-less protocol in the sense it is non-guaranteed protocol. There are chances of the rate at which the data is transmitted over network, it is different from one device to another devices. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start our discussion with the Unit 3, that is presentation layer, transport layer and application layer. Now in this session, we are going to talk about transport layer. So these are topics to be covered in this session. Let us see what is transport layer. So transport layer, as all of you know, it is one of the layer in OSI reference model. And let us see what are the different services provided by the transport layer, or we can say, in other words, what are different responsibilities or functions of transport layer. Now, the first service is delivery of message. So here, an error-free point-to-point communication to deliver messages in order in which they were transmitted in one of the key function of the transport layer. So one of the function of the transport layer is delivery of message from host to destination, and it is going to provide error-free data transmission between host and destination, and it has a point-to-point communication, means it's going to establish connectivity between host and the destination. So that is the meaning of point-to-point connectivity. It's a communication method. It delivers the message in the order in which they were transmitted or which has been sent from the host computer. So that is one of the responsibility of transport layer. And next one is error control and error detection and error recovery. In addition to this, it is also responsible for error control, error detection and error recovery during reliable services, as a part of reliable services or during transmission. And therefore, they are necessary to perform error control mechanism on end-to-end basis. So another responsibility is error control, detection and recovery during data transmission in a computer network. So it is going to provide a reliable services by taking care of error control, error detections and error recovery in a computer network. Next one is to control errors from lost or duplicate segments. The transport layer enables unique segment sequence number to the different packets of the messages, creating a virtual circuit, allowing only one virtual circuit per session. So in order to maintain the error control or error detection and error recovery mechanism, so it's going to provide any data is lost during transmission or duplicated, that can be avoided by giving a sequence number to all the packets which has been sent from the host to the destination. So it's going to create a virtual circuit between the host and destination or for one particular session. So this is how error control, detection and recovery can be maintained with the help of this concept here. So this is another responsibility of transport layer in OSI reference model. Next point is flow control. So what is flow control? The underlying rule of flow control is to maintain a synergy between the fast process and the slow process. So what is the meaning of flow control? So there should be a synchronization or the compatibility between the fast process and slow process. The transport layer enables a fast process to keep pace with the slow one. So acknowledgement are sent back to manage end-to-end flow control. So there are chances of the rate at which the data is transmitted over network, it is different from one device to another devices. So there are chances of different data rate for each and every devices in a network. So that can be controlled with the help of flow control. That is the meaning of flow control here. So here it is going to sync with the fast process and slow process request. That is the meaning of flow control. It is going to maintain the flow control in a computer network during data transmission. Next one is connection establishment and release. So what is the meaning of this? Here, the transport layer enables us to establish and delete connections across the network to multiplex several messages streams onto one communication channel. So here, before we start any communication between the host and destination, a session has to be established between a host and destination computers or devices. So in that way, so transport layer is responsible for, is going to establish a connection, and once the data transmission is completed or all the packets from sender reach the destination in the right order in the same format where the data has been sent from the source computer or the host computer, then it going to release the connectivity or release the connection between host and destination. This is one more responsibility. In the next slide, we will see next concept is multiplexing and demultiplexing. So let us see what is the multiplexing and demultiplexing. So here, to improve the throughput, the transport layer multiplexes several transport connections onto same network connections, thus reducing the cost of establishing and maintaining the network connections. So here, what is the meaning of multiplexing and demultiplexing? The multiplexing is nothing but if there are more than one connection or one session in a computer network, and all the sessions will be communicated or will be combined and will be transmitted as a single channel. That is the concept of multiplexing here. So here, what is the purpose of this? To improve the throughput or to improve the data communication between host and destination. So here, several transport connections. If there are more than one connection in a data network or in a computer network, and all of them will come into one connection, that is the meaning of multiplexing. So what is the advantage of this? One is to improve the throughput, and second one is to reduce the cost of establishing and maintaining a number of connections between the two devices. That is multiplexing. Next one is fragmentation and reassembly. Here, when the transport layer receives a large messages from the session layer, it breaks the messages into smaller units depending upon the requirement. This is called fragmentation. So the entire data sent from the host and it is received from down from application layer to transport layer, and all the data once it has been received from the session layer, so that is going to, all the data is going to break down into number of smaller units to form a fragmentation or to form a frame. So this is the concept of fragmentation. And again, reassembly. I mean, once the data has been transferred from the host to the destination in a computer network and in different sequence number or in the form of different frames, then at the receiver end, the same data packets and is going to reassemble the data packet which has received from the host at the destination end, is going to rearrange the packets in a definite order to generate a meaningful data which has been sent from the host computer. So that is the fragmentation and reassembly of data packets at the receiver end. In the next slide, we will see next one is addressing. So what is addressing here? Another responsibility of transport layer is addressing. So it deals with addressing or labeling a frame. So connection identifies or ports or sockets that label each frame so that the receiving device knows which process it has been sent from, and this helps in keeping track of multiple messages, conversations. Ports or sockets address multiple conservations on the same location. So next concept is addressing. So what is the meaning of addressing here? The transport layer is going to address the different network devices or multiple devices in a computer through the ports as well as sockets. And all the addressing, everything is identified with the help of ports and sockets of multiple devices which they are connected. So the receiving devices or the destination end, it is easy for them to identify which process has been sent from which device. And this is the meaning of addressing. So transport layer is going to take care of addressing multiple devices in a network as well as through ports and sockets. And also it is possible to identify at the receiver end to find out this message or the data packets which are delivered from which ports or which sockets or from which devices. That is the meaning of addressing. In the next slide, we will see what are transport layer protocols, as all of you know that, and each and every layer in a voice reference models, it deals with or works with number of protocols, different protocols. Similarly, transport layer is going to work with, there are two protocols, one is TCP and UDP protocol. These are the two protocols works with transport layer. So here, let us see what is UDP. So UDP stands for User Datagram Protocol. The full form is User Datagram Protocol, and it is a simple protocol and provide non-sequence transport functionality. So as we have seen in the previous session or previous slide, we are talking about sequencing. What are sequencing? So here all the data packets in the network which has been transmitted over a network are numbered in a sequence. So those concepts are not available with respect to UDP protocol. So here is going to provide a communication between the host and destination without any sequence number, or there is no question of sequencing of packets in UDP. It is a connectionless protocol. So that is the reason we say it is a connectionless protocol, in the sense it is non-guaranteed protocol. Or here, whatever the data which is sent from the host to the destination, and there is no guarantee that all the packets will reach the destination in the same format which has been sent from the source computer. So that is the meaning of connectionless protocol. So it is used when reliability and security is less important than speed and size. So as it is a connectionless service, it obviously we cannot rely on this service, as well as security is very less with respect to connection-oriented protocol. So that is the one of the properties, not reliable, and security is very less. And it is an end-to-end transport layer protocol that adds transport level addresses, checksum and error control and information to the data from the upper layer. This protocol is going to is going to take care of the transport level addresses, add checksum and error control and other information along with the data which has been received from the upper layer. Now, the packet produced by UDP protocol is known as the user datagram. So, as we know that, we are going to call the different data packets in a voice reference model in different names in different layers. Similarly, here in UDP, this is referred as user datagram. So, this is UDP protocol of transport layer. Now, let us see the data format, or what is the format of UDP. This is the format. So here source port, destination port, length and checksum. That's what you have seen in the previous slide. Is going to add the address, checksum, error control. All these are available in the UDP format. So this is a datagram format of UDP or UDP header. In the next slide, we will see the description of different parts or different specification in UDP header. So one is source port address. So it defines address of the application process that has delivered a message. The source port address is 16-bit. Is going to find out the source port address from the host computer. Next one is destination port address. So it's going to define address of the application process that will receive the messages, means destination computers, and it is a 16-bit and it is a 16-bit. And again, length, total length, it defines total length of the UDP in bytes. It is a 16-bit field. And one more is checksum. It is 16-bit field used in error detection. So checksum is a field used in the error detection in a computer network. Next, what are the drawbacks or disadvantages of UDP? So it provides a basic functions needed for the end-to-end delivery of data transmission. Is going to provide end-to-end communication between the two devices, and it does not provide any sequencing, as we have seen in the first slide or the previous slide, or reordering functions, and does not specify the damaged packet when reporting an error. So these are the main drawback of this, as there is no question of sequencing here, and there are chances of data loss or data damage during the transmission in the computer network, and it is not going to report the different types of error or the data packets which are damaged or lost. Now, UDP can discover that an error has occurred, but it does not specify which packet has been lost, or it does not contain an ID or sequencing number of particular segment. As there is no question of sequencing here, so obviously it is not possible to find out which packet has damaged or which is the packet which has been lost during network, and those concepts are missing or in the UDP protocol. So this is another drawback of UDP protocol in transport layer. Now let us see another protocol is called a TCP protocol, transmission control protocol. As we have seen in the previous slide, transport layer, it works with the two protocols. They are UDP and TCP. Now let us see what is TCP protocol. So TCP stands for Transmission Control Protocol. The full form is of TCP is Transmission Control Protocol, and it provides a transport layer services to the application. So these are the services what you have seen in the first slide. Services or functions of transport layer, and it is a connection oriented protocol. Means that connection established between both the ends of the transmission. For creating the connection, it generates a virtual circuit between the sender and the receiver for the duration of the transmission. So this is a connection-oriented protocol. The meaning here is going to provide a guaranteed delivery of data between the host and the destination. So any data which has been sent from the host computer or source computer definitely is going to reach the destination computer, because it has so many additional features for error detection, error correction, and error recovery, and also reporting the data loss or which the data packets, or is going to provide a connection-oriented protocol, and is going to establish a connection that is a logical connection, or we say virtual circuit between the host and the destination computer, and as long as the transmission takes place. Means it's going to, as we have seen, one of the property or responsibility of transport layer is going to provide an end-to-end connection, or is going to provide the virtual circuit between the host and destination till the data communication takes place. And once the data communication stops or completed, then it's going to release the connection between the host and destination. So that is the meaning of connection-oriented protocol or connection-oriented service. In the next slide, let us see what are the different features of TCP protocol. So first one is stream data transfer. Means protocol, it transfers the data in the form of continuous stream of bytes. So TCP group the bytes in the form of TCP segments and then pass it to the IP layer, that is Internet Protocol layer, for transmission to the destination. TCP itself segments the data and forward to the IP or Internet Protocol. As we have seen, TCP IP is a network. There are two parts. One is TCP, second one is IP, that's Internet Protocol. IP is nothing but the logical address of the devices in a computer network. So here, is going to provide stream data transfer, means is going to provide or going to transmit the data continuously in the form of bytes, and again is going to form TCP segments. And this, once a segment is generated as prepared and is going to transmit or pass it to the IP layer or internet protocol layer for data transmission, and it itself segments the data and forward to the IP. So it is a responsibility of TCP protocol so to provide stream data transfer. Next one is reliability. So TCP assigns a sequence number to each byte transmitted and expects a positive acknowledgement from the receiving TCP. If acknowledgement is not received within a timeout interval, then the data is retransmitted to the destination. So because of this, we say it is going to provide a connection-oriented service, and we can rely on this. This is a very reliable. So in the sense, first of all, the TCP is going to provide a sequence number to each and every packet which has been transmitted over the network. So all the data packets are sequenced at the transport layer and at the receiver end, and all the data packet which has been received from the source computer, and it will be reassembled in a definite order to make a meaningful data. So, and also another additional responsibility is it expects an acknowledgement, positive acknowledgement from the receiver end. It means that, so each and every packet which has been received at the receiver computer or receiver end, so the receiver computer is, or the destination computer, it sends acknowledgement for each and every packet which has been received from the host, from the source computer. And if the acknowledgement is not received in time, or is a timeout, or in a specified number of time, then that same data packets can be retransmitted to the destination. In that way, it is reliable service from TCP and is a connection-oriented service. In the next slide, it is a flow control. So what is a flow control? So here, when the receiving a TCP sends acknowledgement back to the sender indicating the number of bytes it can receive without overflowing as internal buffer. The number of bytes is sent is acknowledged in the form of higher sequence number that it can receive without any problem. So this mechanism is also referred as window mechanism. So here is going to maintain the flow control, is going to manage the flow control as you have seen in the previous slide, the responsibility of transport layer. So it's going to sync with the slow moving data as well as the fast moving data in a computer network. So it's going to maintain that, or in other words, we can say is going to maintain the flow control between the different data rates at which the data is transmitted over computer network. And this is the meaning of flow control. Next one is multiplexing. So what is multiplexing? As we have seen in the first slide, so it is a process of accepting the data from different applications and forwarding to the different applications on different computers. Multiplexing is nothing but, so it's going to transmit the data. It's going to transmit the process accepting data from different applications and forwarding to different applications at different computers, so destination. And at the receiver end, the data is forwarded to the correct application. And this process is known as demultiplexing. So what is multiplexing and demultiplexing? Multiplexing is a process at the source computer and it has to be demultiplexed, or the demultiplexing takes place at the receiver end. Now, the TCP transmits the packets to the correct applications by using the logical channels known as ports. So, as we have seen in the previous slide, and one of the addressing, so this transport layer is going to address the multiple devices on the computer network through a sockets or the ports. So it's going to provide a logical channel or connectivity through the ports between host and destination. Next, let us see other features of TCP protocol. Next one is logical connection. So the combination of sockets, sequence number, and window size is called a logical connection. Each connection is identified by the pair of sockets used by sending and receiving process. So during data transmission, the transport layer is going to establish a connectivity, is going to provide a logical connection between host and destination through the sockets from sender computer to the receiver computer. That is the logical connection. Next one is full duplex. TCP, it provides full duplex services, means that data flow in both the direction at the same time. To achieve full duplex services, each TCP should have sending and receiving buffers so that the segments can flow in both the directions. It is a connection-oriented protocol. So what is the meaning of full duplex communication? Here, the data can transmit from the host and the destinations simultaneously without waiting for another devices to continue and stop. So here, full duplex means it's going to provide a communication from both the devices, from host and destination, without any hassle or without any problem in the computer network. That is another responsibility of transport layer, that is full duplex. And it is possible because of it's going to maintain the window size buffer between the host and destination computer. In the next slide, we will see the TCP segment format. This is the format as we have seen for UDP. This is segment format for TCP. Again, we have source port here, 16-bit destination port, sequence numbering, acknowledgement number, and we have different type of flags, window size. This is the meaning of the buffer, and this is the pointers. Checksum. Checksum is to find the errors, detect and correcting the errors, options, and data. See, this is the data will be added with the TCP segment. Now let us see the different concepts in detail. One is source port address, as we have seen in the previous slide. So this is the source port. So it's going to define the source port address, 16-bit field, destination port address. This is the address of the destination computer. Again, it is a 16-bit field. Sequence numbering, because it's going to provide a connection-oriented service, the sequence number has to be maintained. So the sequence numbering divided into two TCP segments. One is 32-bit sequence number field. It represents position of the data in an original data stream. Next, acknowledgement number. This is another field. Is a 32-bit field. Acknowledgement number acknowledge the data from other communicating devices. And header length, one more field is header length. It specifies size of the TCP header in 32-bit word. And reserved, it is a 6-bit field which is reserved for future use. And control bits, each bits of a control field function individually and independently. It defines the use of segment of services as a validity check for other fields. Control bits, and again we have flags. We have different types of flags here. One is URG flag. It stands for urgent. ACK acknowledgement. PSH. It is used to inform the sender that higher throughput is needed, so that if possible, data must be pushed with higher throughput with different data rate. RST, it is a reset bit. And again, SYNC, it is a flag. It is used to synchronize the sequence number in 3 types of segments: connection request, connection confirmation, and confirmation acknowledgement. This is a SYN field or sync field. Next one is FIN field, used to inform the receiving TCP module that sender has finished sending the data. That is FIN stands for to indicate the finishing of sending the data from the host. And also window size. This is a buffer size for both host and destination computer. It defines size of the window. Checksum, as we know that it is a field used to find out the error detection and error correction mechanism. Next, urgent pointer and options and padding. It defines optional field that can convey the additional information to the receiver. These are all the different fields of TCP segment. Now let us see the difference between the TCP as well as UDP protocol, both of them of transport layer protocol. Now let us see the difference. So first we see the definition of here. TCP is going to provide a connection-oriented service, establish a virtual circuit before the transmission takes place or before transmitting the data over network. And UDP, it transmits data directly to the destination without verifying whether the receiver is ready to receive or not. That is why we say it is a connection-less protocol and it is a connection-oriented protocol. Means it is going to establish a connection between the host and destination. Then once a confirmation is done, it transmits the data. But in UDP, it is not going to check for any connections between the host and destination. So directly start sending the data from the host computer. Next one is speed. This is TCP is a slow speed and it is very high speed, and because of different mechanism involving in TCP. And reliability. The reliable protocol, as we have seen, is going to provide a connection-oriented protocol with the help of sequence number and acknowledgement concept, but it is unreliable. There is no sequencing concept here in UDP. And the header size is 20 bytes and 8 bytes. And acknowledgement. So TCP, it waits for acknowledgement of data and has the ability to resend the data packets. So it neither takes the acknowledgement nor retransmits the damaged data. So here, what is the meaning of acknowledgement here? So because TCP is a connection-oriented service, it waits for acknowledgement for each and every packet which have been sent from the host to the destination. And it's also possible to retransmit the data which has been lost during data transmission in a network. But when you talk about UDP, it neither takes the acknowledgement nor retransmit the damaged data. And as we have seen, there is no question of sequencing number or sequencing in UDP. It's very difficult to find out or not possible to find out which data packet has been lost and which one has to be retransmitted. See, these are the differences between TCP and UDP protocol. Dear students, so far we have discussed about the transport layer and responsibilities, services, and two protocols of transport layer. They are TCP and UDP. Let us continue our discussion in my next class. Thank you so much.